So in this video, we're going to be looking at histograms where we use a log base 10 scale. And we sort of give you a reason why and how to do it. So for example, here's some data. When I say here's some data, I do mean here's some data that has a whole bunch of populations. So we have populations of cities ranging from Brisbane of 2,200,000, Melbourne nearly 4.5 million, down to Shepparton with just under 50,000. So we've got a really big range of populations. And if we tried to graph that as a by population, as shown here, we wouldn't be able to really, because you'd have stuff down by 100,000, even by looking by 100,000. So we'd have how many in 100,000? We'd have 4 of them. We'd have another 3 between 100,000 and 200,000. And then we got another one at between 4 and 500 spaces. Got some spaces. Then we got another one here, another one here. This means there's a whole lot of spaces there that are empty, and then we get our last one down here. Not really useful to actually to graph that, because it doesn't really show anything of what's going on. And so what we can do is actually use the log 10 function on our calculator. Because you can represent numbers between, so we can represent numbers like this. So 0.1 is the same as saying 10 to negative 2. And, when we then do a log on it, we get negative 2. Okay, so we can represent 0.01 as negative 2 if we log it, which is quite useful. Then we can use between 0.1, hang on, I'm going to change color here. And so that represents that there. And then, as you can see, 1, you go 10 to the 0 to 0, and etc, etc, etc. And you notice that if you get down to here, million, you got millions 10 to the 6, and if you log it, it's 6. Now, the reason I'm showing you that there is, let's get rid of these for a moment, is now we can, when we do this, we can actually say to a histogram and say how many values are between these two. So how many between 5 and 6. Then we can do it between 10,000 and 100,000. So that means it's between 4 and 5. And then we do that sort of process, which ends up giving you something that looks very much like that. Okay, for that same question. Now we'll go back to that, but I want to just quickly show you what that was meaning. Okay, so this is a quick overview properties of logs to the base 10. If a number is greater than 1, its log to the base 10 is greater than 0. If the number is greater than 0 but less than 1, its log to the base 10 is negative. And if the number is 0, then the log is undefined. Okay, so generally you're going to be looking at numbers which are above 0, but sometimes they might be less than 1, and sometimes they might be a lot bigger than 1. Okay, so a lot less than 1, a lot bigger than 1, just to give you an example. Okay, so how do I use my calculator to do this? So you're looking at, here's how you're looking at the calculator, and you can see here's find the log of 45, correct to two significant figures. So two significant figures, I want to look at the first two numbers, that's 1 and that would be 1.7. Okay, now you can actually get I wouldn't say a rough idea, it's not really a rough idea, but you can see that 45, if you think about this here, 45 is going to be between 10 and 100. So it's going to be between 1 and 2. So your numbers should be something between 1 and 2. That's not going to be a linear response, but it's going to be 1 and 2. So you know that. So that means if you get something other than roughly 1.7-ish, something's going to be wrong. Now, what they're doing here is saying I've got a number like that. So in this case, it's 2.175. So the number's already been logged, but I want to find the original number. I put that into my calculator looking like that. And I find that that's 515.822. So it'd be 516. So this one was to the nearest whole number. Okay, so that's how you can use calculator to go from finding what the log value is to finding out, if I've already got the log value, what's my original value going to be. Okay, and this is basically just showing that again in that same process, and we can see that big numbers like that, you'd think that's in the millions, so but it's between, say, 1 million is 10 to the 6. So if I did 10 million, that would be 10 to the 7. So anything between a million and 10 million is going to be between 6 and 7. Okay? And that's why you got 6.65. And you can sort of get a rough idea, whether it's roughly what that first number is, whether it's 4, 5, or 6, just by looking at the numbers. Okay? Now, just keep in mind that when we go between these numbers up here, that basically what I'm doing is I'm going times 10 times 10. I know you can't see that there. Times 10 times 10 times 10. I know I'm being a little bit repetitive here, but there's a reason why I want to do that. Okay, so when we're going between numbers, we can sort of get a rough. So if I'm going to go and say, I've got something that's at 4 and it goes to 6. What's the increase? It's a 100-fold increase. So I'm going times 10 times 10. Okay, so that's what we're doing with these sorts of questions, and that's why this, I can convert that into that. Okay, and here's just another example where there's this body weights. Don't give the values aren't be given, but you can see that the body weights, that's not telling you much as a graph. But if I can convert it to where I've logged the body weight, what I see here is much different. Okay, but you'd have to write it as log of the body weight. Okay. So here's a worked example, which I'm going to skip over for the moment. Okay, I'll take that back slightly. What I'll do is I'll put the numbers in for head, and you can imagine what your graph would be. Okay, so if I log 4,800, that will give me 3.68. If I do 1,100, okay, that's going to be 3.04. Because remember, this is between 100. No, it's between 1,000, sorry, and 10,000. Which, if you log, that's between 3 and 4. Okay, so that's why those numbers are there. So this is 136,000. So if you can imagine that, that's going to be between 100,000 and a million. So it's going to be between 5 and 6. So the number will be somewhere between 5 and 6. So let's calculate that. And that will be 5.13. Okay, I'm going to get rid of these now because we're going to confuse things a little bit. 800, it will be between 2 and 3 because it's between 100 and 1,000. So if I go 800, it will give me 2.9, 140, 2.15, and I realize I'm not being very specific with doing the proper things with my some of these insignificant figures in decimal places, but just for the moment, so I get some numbers. 30,000 give me 4.48. I'm going to skip down to 7. So 7 is going to be between 1 and 10. So it'll be between 1 and 2 in terms of the log value. Actually, I got that wrong. It's going to be between, sorry, I said that wrong. 10 to the negative 10. No, so 10 to the 0 is 1. So between 0 and 1. So I got that wrong in my sort of head there. My apologies. So 0.85. Okay. And so you would plot those out, and then you'd work those out and you plot them out. Now, I'm going to skip one of these things for a second. I'll come back to the other part. Here's where you can do it all automatically. Here's where you put your values. That's those values there. I'm putting them there. Then this is what you would get. The trick here being that rather than doing just this, I can, in my calculator, I actually get the log values. So they're log values already generated for you. And then you do the normal way, you get a histogram. So you don't have to do all of them manually. That would take way too long. Do it in your calculator that's already there. Much easier to do. Or if you have to generate a whole lot of log values, even if you're not going to plot them, much easier to do. Okay, so that's just a way to do that there. Okay, so this is just what I've talked about. It's going back and forth. So Richter scale, which is one we use for magnitude of earthquakes, uses a log scale, log 10 scale. How many times stronger is an earthquake of magnitude 7.4 than one of magnitude 5.2? So this is where I was saying before, it's about that magnitude, that notion of, if I go between, so what we're showing there is I'm going 5.2 going all the way up to 7.4. That's a difference. You can do it 7.4 minus 5.2. That's a difference of 2.4. Okay. So in terms of when we're looking at on the calculator, that's like what we got to do is you got to go 10 times 2.4. We know 10 to the 2 is going to be 100, so it's going to be between 100 and 1,000 times stronger. So if we put that into the calculator, so was it not 2.4, 2.2, sorry, 2.2, that would give us, it's 158 point, what was it, nearest whole number, so it'd be 158 times stronger. Okay, and that's how you do it. You're looking for that value. This is the value you're after. You put that into the calculator and that's what you'll get. So let's go just through one more worked example, just a quick one. So we've got, this is our histogram, and so we're going to say what body weight in kilograms is represented by number 4 on the log scale. You put in the calculator, you go 10 to the 4, and that gives us 10,000 kilograms. So that's what this part means here, 10,000. Okay. So the second question is, how many animals have body weights more than 4? Well, we know that 4 here corresponds to 10,000. So we're looking anything above that. So this is the one we're looking at here. Now, I know in the question here, they said it corresponds to 2 animals. That's basically working out based on this, what they've got here. You've got a percentage of about, I think, just over 5% of 27, so you'd have to work it out. But that's what we're looking at here. It's that one there for that question. The weight of a cat is 3.3 kilograms. Use your calculator to determine the log of its weight correct to 2 significant figures. You basically put in log 3.3 into your calculator. You get that number, and that's your answer, 2 significant figures. Determine the weight in kilograms, whose log weight, determine the weight of the animal. It's 3.4. So that's what it's saying is it's got its log value somewhere here. So it's between 3 and 4. Remember, that's between 10,000 and 1,000. So it's going to be somewhere between 1,000 and 10,000, but we just put that into our calculator and we get basically 2,512. That's how you can use log scales with histograms and these sorts of questions. Okay, thank you. Bye.